This is part 2 of chapter 7.2 notes. So you have your note sheets out. The last section we went through the terms standard normal distribution, looking at z-scores, and then how those z-scores are distributed within the standard normal curve and what percent of people fall within certain standard deviations, which you already know the answer to this. We're just now converting these percents into probabilities problems or probability situations. And so now we're going to apply this. So I just have examples. Let's do examples. Have your StatCrunch ready to go so you can practice this yourself too. So here's the first problem we're going to look at. Pediatrician obtains heights of her 200 3-year-old female patients. So notice here we have a sample, but we don't have the data. All we know is we have the mean and we have the standard deviation. And so with that data, what needs to happen is then we go ahead and label this the way we've done in the past. The mean is going to be in the middle. The mean here is going to be equal to 38.72. And then we mark these off like you've done in the past. Okay, because that's going to represent the percent of students. We don't have the data, so what we're going to do is we're going to approximate. We're going to approximate the distribution with a normal curve, since it said it was normally distributed, and that's again a key term right there, normally distributed. We don't have the data for everyone, but now what we can do is, since we know it's normally distributed, we know it's going to follow this shape here, and so then we have a nice curve. From there, though, we could also complete certain values. The standard deviation is 3.17, so now I know that this value here would be 41.89. This value over here is going to be, you're going to subtract 38.72, 7.2, 32.72, 38.72, that value there. We know this value here. Let's go this way anyways up. So add a 3, so that's 44. It's going to be 45.06. If we continued on, 3 standard deviations, this value here is going to be 48.23 and so forth. And so we would have these values. Now the question is being asked, what is the proportion? Use the normal model to determine the proportion of 3-year-old females who have a height less than 35 inches. So we want the proportion of the probability that one of those 3-year-old females has a height less than 35, and that's what we need to calculate. So where is 35? So 35 is going to be somewhere on this side. So let me calculate this first standard deviation below. That turns out to be 35.55, and then we also can determine that the next standard deviation will be 3.17 below that. So then this one down here is 32.38. And so 35 is somewhere here. And the proportion of students, or I'm sorry, 3-year-olds is going to be the area right here. So if I can calculate that area, what is that area equal to? I have the answer right there. That's going to be the area, whatever I can do. So how do we do that? We're going to go to StatCrunch. So StatCrunch is open, and I have my standard normal calculator again. Stat calculator normal. And in this case, I'm going to change the values. So we're not talking about the z values or the standard normal distribution. We just have the distribution of the 3-year-olds. So the mean height was, better get that data right, 38.72. So we put 38.72 there, and then 3.17 is that. And again, I want it to the left of 35. So you compute, you can see a nice picture here. StatCrunch only gives you the option the less than or equal to, so we would choose that. And then it's 0.120. And so in this case, then we know the area is equal to 0.120. And so then what we have here is 0.120, or 12% of 3-year-olds are less than 35 inches. That's it. That's how we solve that. So we always have to draw that curve. Let's move on to the next one. Get through this. Pediatrician obtains, so we have the same situation, and so we have the same graph, and so we have the same picture here. And so what we care about on this, there's the distribution. Here's 35 and here's 40. The middle, I'm going a little faster because it's the same scenario. The middle is 38.72. And so what we care about here is the probability, or the proportion, determine the probability that a randomly selected 3-year-old has a height between 35 and 40. And so remember, here we use the term proportion. The heights, where is it? Oh, right there. What proportion? Here we're using the probability, and that came back to the previous lecture where I said, important, understand this. Area underneath the curve represents the proportion or a probability problem. And so on this one over here, finishing that off, it's the same picture. Here is 30, I'm approximating, here's 35, here's 40. And so what we care about is whatever this area is. And it's a big number because this is where most of the people are in the middle, most of the 3-year-olds. And so calculate that. We go ahead and use the between. Use the between. Oh, I didn't know I could use that. Oh no. Use the between here. Use the between here, and we were going to go, oh no, that's the same. We want between 35 and 40 and compute. And so we can see the answer between 35 and 40 is 0.537. Actually, I just noticed that you can click that. It will mark it off by standard deviations for you also. But from 35 to 40, and so it's 0.537. And so this area here, what is that area? It turns out to be 0.537. That's the area. So there's a 53.7% chance that a 3-year-old is between 35 and 40 inches inclusive. So we have that there. Okay, let's move on to the next one. The heights of, here we go. Same question again. So we have the same picture. In this case here, where the question is being altered a little, so important to answer here. We have the same, find the height of a 3-year-old female at the 20th percentile. Oh, so this is a trick, not a trick question, a question that's going to have you think a little bit deeper about it. So we're looking for what's the height, right, of someone in the 20th percentile. So what we're looking for is P20. 20th percentile means, again, percentile is 20% of the people are below this. And so what I know is the mean is 38.72, right in the middle. And so half of the people are below this, half are above. 0.20, 20th percentile, it means 20% of the 3-year-olds would be below this height. So here I'm looking for a height, not an area. They've given us the area. This here is now the area. They've given us a percent. Remember, percents are areas. And so what we're looking for is I'm looking now for this x value, this height right here, when the area is 0.20. And so that's the key. And I'm going to the left because this is a percentile. And so we're looking for P20. What is this height? Right? what is this height x right there? And so we use StatCrunch to do this. The instructions to do this one are here. Find a score corresponding to an area. So we were given, so you were going to use the Save Normal calculator. We were given an area this time, and so now we want to find the x value that's associated with that. And so we're going to go here, and in this case, we have the mean and standard deviation. Here's what we're going to do. We're going to clear this off, and in here you put 0.20 here in the area over here on this side right here. We're putting 0.20 because this is an area, and now we're looking for the x value. Compute. I have the less than, and so what we know is the height of 36.05 inches is now our 20th percentile. So it's asking the reverse question that we were asking before. We were looking for the x value here, and so I already forgot what it was. The x value is 36.05. So what is P20? P20 is 36.05 inches. So we used, again, StatCrunch. We use StatCrunch to find this value right here. I use the less than because I want those less than values. If it said what's greater than, or the top 80%, we could have used the greater than, but we used the less than because we wanted to the left. And so there's our answer. This is, again, finding a value versus when you're given the area. And so I was given an area, we found a value. Important change in that question. Continue on, just doing examples and examples. Here we go. Finding the value. So let's try this problem one more time. Different context now. Scores are earned on the mathematics portion of SAT college entrance exam are approximately normally distributed. Key term, normally distributed. So once I hear that, I'm going to go ahead and draw out what I have. Mean is equal to 516. I'll go ahead and mark off the standard deviations. Just approximating. These values turn out to be 116, so this is 632, this is 748, this would be 864. Coming back, the mean was 516, so coming back 116, this is 400, this would be 386, and this would be 272. One standard deviation, that's where the inflection, so I like to sketch out my curve. There's the top, and then you continue down like this. So I have a good approximation. What scores separate? So I'm looking for scores now, and I'm given, so we're looking for scores, and I'm given the middle 90% of test takers. And then we want the top 5. So let's go. We have two situations here. So in the first situation, the middle 90% means that there's, let's try this again. What scores separate the middle 90% of test takers from the bottom and top 5%? Okay, got it. And so this, remember, this graph represents everybody. And so what we're looking for somewhere over here is we're looking for the bottom 5%. And so somewhere top 5 and bottom 5%. So we want, let's change colors here. We want 5% area somewhere over here, 5% area somewhere over here. That's 5%. And here is the middle 90%, all equals 100%. Here is the middle 90%. And so what we're trying to find are what are these scores right there. And so we have our, again, this is complicated if we were going to use formulas and stuff. We're going to use StatCrunch. And so we go back to the mean was 516. I don't think we can use this. Mean is 516. 116 there. And so what we need to do is we put those means. So I want the bottom 5%. So I'm first going to take that off. I'm going to put 0.05 here, 0.05. And so I'm finding right now by doing this 0.05 with that mean and standard deviation, what I'm doing right now is calculating this value right here. This is the one I'm calculating. I'm trying to find out that value that separates the bottom 5% from the rest of the group. Compute. And so you get 325.20. 325.20 is the value there. And so this number here is 325.20. And then I'm looking for this one over here. So we're going to use the same setup. The only difference is I'm going to change this to greater than, and now I got 706.80 for the top 5% over here, 706.80. And so this here is 706.80. So these were the scores that separate from the middle 90% from everyone else, or another word is find the 5th percentile and the 95th percentile. Those are all equivalent statements. There we go. So you just got to practice that. And then so the next thing we got is to finish this section off, we have one term. So sometimes we're going to use this later on. What's called a z-score or critical value. And so you see this notation z alpha. Z sub alpha, you'll see this notation there. So you might hear me say, what's your Z alpha? That's how we pronounce that. What is Z alpha? Let me see if I have it in my notes right here. Pronounce Z sub alpha. Z alpha might be for short. Sub means it's a small letter. It's the z-score such that the area under the standard normal curve to the right of Z alpha is alpha. And so all we're getting, you want to copy that down into your notes right there. All that is you're copying that down is what's the area, what's the area of, or what's the z-score when the area is alpha, right? What's the z-score? Such that the area under the standard normal curve to the right of the z value is alpha. So let's just look at what that means. There's a picture of it. There's alpha as your area. We're just using that as a variable. Alpha stands for area. And so let's go ahead and do an example. You can write that down into your notes. And so what we're trying to calculate right here when it says find z sub 0.10 right here in this problem, that means your alpha is 0.10. And what that means is, real simple, there's your normal curve. All we're trying to find is Z alpha when this area right there is equal to 0.10. That's all. If we were going to do the next one, and this area to the right of that Z value, Z is 0.0, this would be Z.10. In this case, we're looking for right here. This is Z.01. This area here is 0.01, or your alpha is 0.01. So instead of saying what's the area, we can say what's your alpha, 0.10. And to answer those questions, we just go ahead and use StatCrunch. So what is Z sub 0.10 for that first one? Just go here. This is the Z value. So let's go back to mean of 0, standard deviation of 1. Clear this out. We want it greater than to the right. And you just put 0.10 here. Compute, and now you have it 1.28. And so the answer to this one here, what is Z 0.10 is equal to 1.28. That's the Z value right there. What is Z 0.01 equal to? Go back to here, and then let me clear that out. and you put 0.01 in there, compute, and now you have 2.33, and that's it. This would be 2.33. Hope that's helpful.